Okay, good morning, good afternoon, good evening. I'm gonna do this pretest non-stop. So, first page is a multiple choice, 20 questions. You got one. What is a mole? Is a international system unit used to describe the number of particles of a substance that are present. 2, which is Avogadro's number, 6.02 by 10 to the power 23, the number of particles in a mole. 3, what is the molar mass? A general expression used to refer to the mass of any substance, okay? And what is the empirical formula? A notation showing the lowest whole number ratio of atoms in a compound. 5, what is the molecular formula? A chemical formula of a compound that is the empirical formula of a compound multiplied by a whole number subscript. For instance, CH2 would be the empiric formula of C2H4. 6, what is the formula mass? The formula mass is the mass, the sum of the atomic masses of molecular compounds, okay? Sorry, ionic compounds. That's the formula mass. And the molecular mass, the sum of the atomic masses of molecular compounds. 8, what does the law of conservation of mass state? Mass is conserved and is neither created nor destroyed. 9, what is a chemical reaction? A process that involves changes in the structure and arrangement of atoms and molecules. What is the percent composition? The mass percent of each element in a compound. What is a compound? A substance composed of multiple elements combined in fixed proportions. And what is stoichiometry? The relationship among the relative quantities of reactants and products in a chemical reaction, okay? The other 8 are molecular masses. Do you know how to calculate it? For CO2 would be C weights 12 and oxygen weights 16, so 16 by 2, 32 plus 12, 44, okay? And so on. H2, H is 1 by 2 is 2. And nitrogen is 14 by 2 is 28. O2, O is 16 by 2, 32. CH4, CH12, and H is 1. 12 plus 4, 16. H2SO4, we did it the other day, is 98. Sodium is 23 plus 16 is 39 plus 140. And F is 19 by 2 is 38. Okay? So first exercise, how to transform moles to molecules. So we have 5.6 moles of whatever. In this case antidote, you only have to multiply by 6.02 by 10 to the power of 23 and divide it by 1. And that way, you turn it into moles. Okay? Into molecules, sorry. Moles to molecules. Ay, mío. Five point six. 33.712 by 10 to the power of 23. Okay, it's easy. Next one. Do you need time to copy it? One minute. You have to turn it in. You have to turn it in and everything must be done. You have to turn it in. Can I go on? I go on. Molar mass. Remember to calculate the molar mass. So for sulfuric acid atom has hydrogen, sulfur, oxygen quantity, 2 hydrogens, 1 sulfur, 4 oxygens, weight of hydrogen 1, of sulfur 32, of oxygen 16. I multiply 2, 32, 64, and you get 98. Okay? That's how you calculate the molecular mass. You have 1 minute. You have to turn it in. Okay, I go on. Grains to moles, calculate the moles in 300 grains of water. For that, you write the quantity of grains here, 300 grains. In the formula, water, H2O. And then you have to know the molecular mass of water. That is 16 of oxygen plus 2 of 2 hydrogens, 18. And then for this, you take your multi-purpose computer, you call it cell, and you use it to spend your time doing nothing productive. But this is a multi-purpose machine. It's a calculator or a learning machine. 16 moles of water, okay? To turn grains into moles, you have to divide by the molecular mass. To get the molecular mass, you have to do the table we did before, okay? So it's easy. To get the number of moles from grains, you only have to divide by the molecular mass. Okay? 1 minute. Thank you. Can I go on? I go on. Moles to grains. If you're getting from grains to moles, you have to divide. If you have moles and want to get grains, you have to multiply. You got 2 moles of water, and 1 mole of water is 18 grains. So you get 36 grains of water. Again, from grains to moles, you have to divide. From moles to grains, you have to multiply. It's inverse, okay? It's that easy. Don't have to think too much. You have 2 moles, you multiply by the molecular mass, you get the grains, and if you got the grains and you want to get the moles, you divide by the molecular mass, okay? 1 minute. Okay, I go on. Percent composition of sulfuric acid. So to get the percent composition, you have to do this table. It's a table like the molecular mass table, and you have to add this column, okay? In this column you divide the total mass of each atom by the total molecular mass, that is 98, okay? Here would be 2 by divided by 98, here would be 38, 32 by 98, and here 64 by 98, okay? You would get like 2.01, I think, and here you get like 32.6, something like that, and here you get 64, like, I don't know, like 4 or something, right? Okay? That's the percentage of each atom in the molecule, okay? The percentage of mass. Again, you have to divide. You do the molecular mass, the same table we did before, and we add a column where we divide this number, the total mass of each atom, by the total molecular mass of the molecule, okay? It's so easy. You had a worksheet like Excel or Calc, it's so easy to do. 1 minute. Okay, next one. How to get the molecular formula from the empiric formula. To get the molecular formula from the empiric formula, you have to have the molecular mass and the empiric mass, okay? And you divide the molecular mass, 28, by the empiric mass, that is 14, and you get 2. And this number, you multiply the formula by this number, by 2. So, this is the empiric formula, and the molecular formula is the double. You multiply by 2 and you get the molecular formula would be C2H4. Okay? The molecular formula is always the empiric formula by a whole number. Okay? Here you have this division. They have to give you this. If they don't give you this, you cannot do it. And you divide the bigger number by the smallest number and you get a ratio. This ratio is the relationship between the molecular formula and the empiric formula. Okay? Easy. Next one. This is the one we have just done, so I'm not going to do it. Do you know how to do it? And that's all. Okay? So do it and turn it in.